Hi, Dr. Jenny Sue. Thanks for joining me. In this quick video, we are going to look at how to use an inquiry analysis tool to identify if a lab or activity is an inquiry-based experience. And then we're going to have a conversation about how you can redesign a lab to make it more inquiry-based. All right, let's get started. Let's start with why we need to be doing inquiry-based science in our elementary and secondary classrooms. Inquiry-based science challenges students to think by engaging them in investigating scientifically oriented questions. These are questions that go beyond topics that can just be Googleable. They are questions that real scientists are studying in the world. We want students to be investigating scientifically oriented questions because that's what real scientists do. And our classroom experiences should mirror the real world. This way, it allows us to also talk about those real world scientists like George Washington Carver and Katherine Johnson and the impact they made to science education and to our world. It also allows students to see people who look like them. They can then see that they can be scientists. How do we make sure that we are using inquiry-based learning experiences in our science classroom? The process really is simple, and in this video you're going to see the steps that I go through to make sure an activity is aligned. Step one is make sure it's aligned to the standards that you are teaching. This is really critically important because the activities in your classroom should help your students to get to those learning standards they need to achieve. In this video, I'm going to show you how I assessed a lab to see if it would work with SOL 2.3, which is in the second grade, and it deals with matter existing in different phases. Now, a unit of study would be developed around this entire SOL, but for the purposes of this exercise, we're just going to focus on a few of the learning standards. Those are highlighted here. We're going to be looking specifically at the standard that asks students to plan and conduct an investigation to determine how factors affect the evaporation of water. So, in searching for activities, I'm specifically looking for something that is dealing with matter changing phases, looking at heat and how it would affect it. So here's the activity. As I go through and read the activity, I can see that students are placing one sample of water in a sunny spot and the other one in a cooler spot. And I see, of course, the word evaporation used in the lab. But when I look at this, I notice it's more of an experiment testing location rather than helping students understand evaporation. But I can use this if I modify it. But I got to make sure that it's inquiry-based. So once you know the activity or lab is assigned to your standards, the second step is let's determine if that lab or that activity is actually inquiry-based. Does it have one or all of the features of inquiry? Here is the inquiry analysis tool that we will be using. It was developed by Volkman and Abel, two science professors, and it's a checklist that's based off the essential features of inquiry. Let's look at the first essential feature of inquiry. Does this lab or activity engage students in a scientifically oriented question? So as I'm looking through the material, I'm looking to see what are the questions that the lab or the activity asks students. Does it engage them in a scientifically oriented question? As you can see, the questions in this lab activity are actually at the very end of the lab. When in reality, the students need to know what is the question they're investigating? What are they trying to find an answer to? And that is not clear from this lab activity. So as I'm going through this checklist, I'm already seeing that it doesn't engage them in a scientifically oriented question. It doesn't have them talk about generating investigations. But the one thing that I do notice is this a worthwhile experience for students to go through? And I do think this has potential. And so I gave it a yes, because what if I took that question at the end of the lab and I reworked it, and that was the question that was given to students at the beginning, or we worked together to develop that question. so that they would understand this is what you're trying to find the answer to. The second essential feature of inquiry asks students to give priority to evidence. In other words, the students are determining what data they're going to collect. They're developing data tables, or the teacher is helping them to do this, or the teacher gives it to them. But it's all about what is the evidence that they're going to collect in the investigation. When I look at this lab, it doesn't really have anything for the students. Like, it doesn't specifically say you're going to record measurements of change. It does say that the students are going to do something. They're going to place one dish in a sunny spot and they're going to place another. And it asks them to predict which will evaporate first. But my question is, do students even know that water evaporates? So as I look at this, giving priority to evidence, I have to ask myself, is it really allowing them to do this? Not in its current form. But as I'm looking at it, I can really see how I could redesign this to specifically ask students to develop a table that would measure change over time from a beginning amount of water to an ending amount of water. And students could do that in second grade, or I could give them a chart that asked them to collect that data. And we could talk through why we are collecting that data, which is a valuable experience for second graders. So again, as I look at this, while I might rank these no on the inquiry analysis tool, I still think I could modify this. So I really am liking this lab because it does go with, specifically with planning and conducting an investigation on evaporation, but I know I need to keep tweaking it. The third essential feature of inquiry in this analysis tool encourages students to formulate explanations from evidence. In other words, they're taking their data, they're analyzing it, and they're making sense of it. What do they think that the data tells them about evaporation? And so when I look at this, I don't really see students doing this. But again, could I add some questions to engage students in that process? The fourth essential feature of inquiry in the analysis tool is looking at learners evaluating their explanations in light of alternative explanations. So in other words, if students have found data from their investigation and they read something else, do they come back and make more sense of their data? Or does it cause them to think differently about their data based off that information they've learned? Again, I don't necessarily see that in this quick lab, but I still feel like I could add it. The fifth essential feature of inquiry in the analysis tool asks learners to communicate and justify their proposed explanations. Again, when I look at this lab, I don't see where students are talking to each other or being directed to. Again, I know that the teacher's probably going to do this, but again, I think that it needs to be clearer in this activity, and especially the lesson plan should help teachers to be able to do this. So right now, when I look at this overall quick lab, I see one essential feature of inquiry found in this lab, but like I've been saying, I really think that I can modify this quick lab to do what my standards call for my students to be able to do, which is plan and design and investigation. So here are the steps that I go through to redesign. So in this first process of redesigning it, I have to think about what about the lab or the activity connects, what works and what connects to your content. So with this, I really like the idea of students observing changes in the water. It is more experimental in nature because they're already changing two locations. So I'm not sure that I want my students studying that first. I want them to see that water can evaporate. So I like the idea of it, but I think what I need to do is I need to simplify the activity by starting with that one experience. So yes, I can do that. I can have them start with just measuring water out in a location, and over a week, they're gonna measure the amount of water they put into the beaker and then how much is left after a week. Again, this gives them great practice measuring, reading a graduated cylinder, looking at volume, and then I can connect it to the definition of evaporation, and it really gives me a good experience. The second step is, if it already has experimental nature, if it's experimental in nature, can I then go back and use it if my standards say plan and design and investigation? And of course, with this, yes, it's already written in an experiment I want to guide my students to come up with this idea of changing the location. So I can use the modified version of the 4-question strategy to do that. And so step 3 in this is, would I really need to create some things for my students to do this investigation? Yes. I want to either create a data sheet, or I want to plan in my lesson for students to create a data sheet for that first descriptive investigation where they're measuring before and after. I then want to create that experimental design recording sheet for my second investigation that's going to hit my learning standard of plan and design, conduct an investigation. And then I want to have that data sheet for that investigation created as well. So again, as you can see here, this is the first descriptive investigation. So what's on the right is the change from what the activity was originally. So you can see that the investigation question is, how does water change after sitting out by the window for a week? Students would measure before, they would then measure after a week, and they would note the changes. Notice they would have to then, I would lead them into designing their experiment, planning and conducting an investigation. And so I would use the 4-question strategy. Here's what students have brainstormed before. These are all the independent variables that they came up with. We picked one thing that we would change, and that's the location. So the students designed that they would change that location. And that's the best part about the 4-question strategy, is it really puts the control to the students. The last part of the strategy is, so if we make this change of location, what are we going to observe or measure? And so this is what the students said. Well, just do the same thing we did before last week. We would measure the difference in the beginning of the investigation and the end. So if we're changing the location, putting one by the window and one in a dark closet, then we would measure the difference in the amount of liquid. And that would help us to see if the location makes a difference. So here is the after of modifying that lab. Again, this is a lot more cookbookish in terms of students following those procedures. So if I knew that my students were ready to develop their own procedures, I could certainly have the students do that. Again, you can see the questions at the end. Kids have to write down and to process, does that location make a difference with evaporation of water? So hopefully you can see that through this process, there's a way that I can still use a lab even though it may not be in the form that I need it to be in when I'm ready to use it. So finding those activities and then modifying them are very helpful. Hopefully from this video you can see that modifying the labs are simple. You just have to find a really good lab activity that's aligned to your standards to start with, and then think about how you can use it in a different format.